Welcome to WarTech Lab, where billion-dollar war machines face forces they were never meant to survive, and somehow still do. Imagine a floating city, cutting through a violent ocean before a storm fully arrives. Waves rise, winds accelerate, and lightning tears across the sky. On that deck sits something far more fragile than steel: billions of dollars in aircraft. Each one exposed, each one vulnerable. Because out here, there is no shelter, only preparation and survival. An aircraft carrier isn't just a warship, it's a mobile air force. Dozens of jets line the deck and fill the hangar below. Fighter jets worth tens of millions each, surveillance aircraft, next-generation stealth fighters. Add it all together, and you're looking at over $5 billion in aircraft alone. And all of it sitting on a runway that moves. In extreme weather, control becomes fragile. One loose chain, one small mistake, and suddenly, physics takes over. In July 2022, that risk became real. A single FA-18 was torn from the deck and lost to the sea, plunging thousands of feet into darkness. Because when wind and mass collide, even a fighter jet can become a projectile. The threat is constant, and it's unstoppable. Hurricanes with winds over 150 miles per hour, waves crashing high enough to flood the deck, storm seasons that last for months. And yet, carriers don't stop. They don't retreat. They don't hide. They operate 24 hours a day, 7 days a week, in the middle of it all. So how do they survive? They don't fight the storm. They face it. Carriers turn directly into the wind, pushing forward with massive power. By doing this, they reduce the force hitting the deck and stabilize the ship against the waves. Powered by nuclear reactors, they don't slow down. They don't wait it out. They move deliberately through the storm itself. At first glance, an aircraft carrier looks vulnerable, a massive structure rising above unstable water. But its strength is hidden in physics. Its center of gravity sits deep, anchored low within its 100,000-ton body. Meanwhile, its buoyancy is engineered to stabilize from above. So when the ship tilts, it doesn't lose control. It fights back, naturally. Like a pendulum correcting itself, the more it leans, the stronger the force pushing it upright. But physics alone isn't enough. Beneath the surface, a hidden system is constantly working. Sensors detect every wave, every shift, every roll. Computers instantly calculate the exact counterforce needed, and within seconds, massive stabilizer fins extend into the water. They push back against the ocean in real time, keeping a 100,000-ton warship steady enough to operate. When the storm intensifies, the most valuable assets disappear from sight. Below the flight deck lies the hangar bay, a steel sanctuary stretching hundreds of feet. Elevators move aircraft down, away from the chaos above. Inside, thick reinforced walls divide the space into protected zones. But even here, danger remains. Fire suppression systems rely on seawater, a solution that can save the ship, but destroy sensitive aircraft systems if not handled perfectly. Even with that massive hangar, there's a limit. Not every aircraft fits below. So during operations, many remain exposed on the deck, parked tightly, wingtip to wingtip, on a surface that never stops moving. To make it possible, every jet is engineered to fold into a smaller profile, because without that, there simply wouldn't be enough space to survive the storm. And in the end, everything comes down to something simple: chains. Heavy steel tie-downs lock each aircraft into place, anchored directly into the deck. Each one built to withstand immense force, tens of thousands of pounds pulling in every direction. But salt water, stress, and time wear them down, which means survival depends on constant inspection, constant maintenance. Because if even one fails, the storm doesn't hesitate. Securing a fighter jet isn't just about tying it down, it's about controlling force. In calm conditions, a jet may use 4 to 6 chains. But in a storm, that number triples. Chains are placed in opposing directions, creating a perfect geometric lock. No slack, no movement, no escape. A 30-ton aircraft becomes part of the deck itself, locked in place by pure tension and precision. On the surface, it looks chaotic, but every movement is controlled. Each crew member is identified by color: yellow directing aircraft, blue securing chains, green handling critical systems, red managing weapons and emergencies. No confusion, no hesitation. In hurricane-force winds, this color-coded system becomes the difference between order and disaster. Above it all, there's another battle happening. Data flows in from the sky, weather aircraft cutting through the storm, feeding real-time intelligence back to the carrier. On the bridge, decisions are made instantly: course adjustments, speed changes, lockdown orders. Every movement of the ship and every aircraft on it is guided by information. Because in a storm, guessing is not an option. These systems weren't invented in comfort, they were built from failure. In 1944, during Typhoon Cobra, violent seas turned aircraft into deadly projectiles. Fires broke out, planes were lost, lives were lost. That chaos left a mark. Every protocol used today, every chain, every checklist exists because of moments like that. Hard lessons, written in steel and memory. Surviving the storm isn't the end, it's just the beginning. Once the waves settle, nothing resumes immediately. Every aircraft is inspected, every chain is tested, every system is verified. Salt water corrodes, stress weakens, hidden damage can't be ignored, because launching too soon could be more dangerous than the storm itself. At the center of everything is balance. Not just strength, not just technology, but 3 systems working as one. Hardware, chains, stabilizers, the physical force holding everything in place. Architecture, the ship itself, designed to absorb chaos. And protocol, the people, trained to respond without hesitation. Remove one, and the system begins to fail. Even at its peak, there is friction. Losses still happen. Mistakes still cost. Because in extreme conditions, there is no margin for error. Now compare that system to the rest of the world. Not all carriers are built the same. Some rely on fuel. Some rely on timing. Some rely on calm seas. But one system was built differently. Nuclear-powered, catapult-assisted, designed to operate not around the storm, but through it. This is where capability becomes dominance. Not just surviving the ocean, but controlling the conditions of war itself. And in the end, this is what it all leads to. A ship that doesn't hide from the storm, it uses it. While others wait for better conditions, this system keeps moving, keeps operating, keeps fighting. Because the goal was never just survival, it was readiness. Anytime, anywhere, no matter the cost. If this story kept you watching, there's a lot more you haven't seen yet. Follow WarTech Lab, and we'll see you in the next breakdown.